Okay, in the previous video we talked about how to find an exponential function if we happen to know the y-intercept, which we said was the number y0, the number in front of the b to the t. Again, your homework used the number a instead of y0. But what we want to talk about now is what if we don't know the y-intercept? So neither one of these is given to us in terms of what's the starting amount. I don't know what the y is when t is equal to 0. I only know what the y is when t is equal to -2 or 3. And so this is a little bit trickier of a problem to start off with. Let's try and plug these two pieces of information in. I've written them two different ways, as a table or as 2 points. It's the same set of information. Let's try and plug these into the equation. So our y, or f of t, is the 3/2. We don't know y0, and we don't know b. In this case, we do know t is -2. In this other case, we have 48 is our f of t, so the left-hand side of the equation is 48. We don't know y0. We don't know b. We do know that t is going to be 3. Okay, so what we actually have here is a system of equations, which means two equations that go together, and we have to solve for the two variables, which in theory can be kind of tricky to solve. It turns out this particular system of equations isn't going to be terrible. We are going to have a strategy to solve for it. So I'm going to try something sneaky to solve this. What I'm going to do is I'm going to try and divide the two equations. And I'm actually going to do it the opposite of the order they're in now, because I would rather have my bigger exponent in the numerator. So I'm going to take and divide these two in the opposite order. So let's do 48 over 3/2. And that should be the same as y0 times b cubed divided by y0 times b to the -2. So the idea is if 48 is equal to this number and 3/2 is equal to this number, when we divide those, both sides, both fractions should be the same. But the idea here is, the way I've done that, I can cancel out my y0s. And so what's left is b cubed divided by b to the -2. Remember, a negative exponent moves you from numerator to denominator, so it's really b cubed times b squared. And dividing by a fraction is multiplying by the reciprocal. Okay, and so if you have b cubed times b squared, that's add the powers, so b to the 5th. And 48 times 3/2, let's cancel a 3. 48 divided by 3 is 16, and 16 times 2 is 32. And so you might know the answer to this one off the top of your head. If not, don't worry about it. We can take a 5th root of both sides to solve for the b. So b is the 5th root of 32. You can write that as 32 to the power 1/5. And if you type that in a calculator, you will get the number 2. And so we now know the number b is 2. Once we know the number b, we plug back into one of our original equations, and we should be able to solve for the other variable, which in this case is y0, or in the homework it's going to be the letter a instead of y0. Again, I'm using this because this is the notation in the book. Okay, so let's now try and plug this b into one of our other equations. So let's try the bottom one, because I don't really like the negative numbers and fractions in the first one. I like this one a little bit better. 48 is equal to y0 times b, which is 2, to the power 3. So just taking this equation and replacing b with the number 2. And now 2 cubed is really 8. And so 48 is equal to y0 times 8. If we divide both sides by 8, then we get a number for y0, which is 6. And so our answer would be just plugging in the b and the y0 into the original equation. F of t is equal to y0, 6, times b to the t, which would be 2 to the t. And again, if you wanted to, you could put parentheses around the exponent. Don't put parentheses around the 6 times 2. Don't turn this into 12 times t, or 12 to the power t.